Let me share my screen. So any new resolution or same for 2025? Huh? Same eskona? Same? What about online? I know one thing is job. That I know. Any other? No. 2025 also I think same resolution, right? Job only, right? Maybe freshers are different. Abroad, car. Okay, okay. Agreed to buy a car. Next. I mean, car for me or you? I think you guys are promising me, right? Uh, if I get a job, one car, one house, villa, na? Villa. One villa. Both. Oh my God. Okay. So this, guys, these 10 days are very important. Okay. We'll discuss projects and all. Second gap will come. 3-4 days holidays are there. I don't know exactly the holidays. So please utilize these holidays and do the practicals. I know festival time you are busy, but still at least 2-3 hours spend time for your career. Then have a fun. I don't have any problem. Okay. Any questions from anyone? Hmm. 1 hour. Gym, yoga, workout, Jan first, all are common. You just say, okay. Anyway, from Jan first onwards, from Jan first onwards. So this dialogue is most famous right everywhere. Even my inter BTech onwards also same. I'm using this January first onwards definitely. So this I think 1 week only. Kiran, this is only for 1 month. Might be no 1 week only. Some cases. Anyway, I appreciate it, guys. If you really work around to you know get success in 2026, but don't waste your time, please. Okay. Definitely every year, definitely we learn something, right? So 2025 also, first, what you learn is very important from the 2025. I'm not talking about cloud and DevOps, okay? Anything, what you learn from the people, what you learn from the, whatever it is. So please fix and something in your mind. So don't do this kind of mistakes in 2026 also. This is main resolution, my point of view. Okay. Don't do same kind of repeats in 2026 also. Everyone can definitely do a mistakes. It's a common. But 2026, try to hi. Yeah. So 2026, try to minimize it. Okay. Anyway. Okay. So, guys, two things. And the first one is coming to the Kubernetes. So from now onwards, I will give more tasks to you. Mostly Kubernetes 90% I covered, guys. No doubt on this. 90% enough. Whatever Kubernetes concepts we discuss, 90% enough for 4 to 5, 6 years experience range. Service mesh only pending. That is Istio service mesh, not required for your for experience. I'll plan a workshop for that, no doubt. That is only the concept I not discussed. Even not any batch I haven't covered that concept. It's a different story. Leave it. COPS process is there. One is, control node managed by AWS. That control node also, control node server, we can also manage. It's a COPS process. So you can try from your end just 4 commands only. Okay. So here you can see But to do this process, we need a DNS, domain name. API, all requests will go through your DNS name. That integration is required. And S3 bucket also required to store the cluster state information. These two are additionally you have to follow. So yeah, this is a process. Very easy. How I set up Kubernetes cluster on AWS easy to using kops. So now, for example, create IAM role, everything is very clear. Install the kops inside the one server. Like we have installed EKS ETL kubectl one server client server. And next, check the kops version and set up S3 bucket to store the state file of the DNS, etcd. Can you close the door, please? Yeah. So make sure your DNS is set up right. So then create a cluster. That's it. Update a cluster and validate the cluster state into the S3 side. So after that, you are able to see total 3 nodes. One is for control plane, one is for worker node. So kops engine will give control plane, the control plane not managed by AWS, managed by you. That's it. For this process, you have to take care, install kubectl to run a commands, and S3 bucket is required to manage the state file. That's it. These 3 activities you can do, and let me know if you are facing any issues. Here you can see kops update cluster name and all I'm giving, right? I haven't mentioned any number of nodes here. Hyphen nodes, if you mention number of nodes also, it will give minimum, maximum and all. If I'm not mentioning, by default, it will take 2 nodes, like a same EKS cluster. Okay. Finally, validating command to store everything into S3 bucket. So do it today. Route 53 should create first. The DNS name we have to give. So here, kops installation, then DNS here, not here. Yeah, create cluster, your DNS, your state S3. Okay. And here you see node volume size is master volume size 2. Like this, if you can give. This is the main command to create a cluster. How many nodes? Okay. See, node count I have given 2, right? Size is t3.micro something. You can change node count 3, 4 also. But to create to run this command, DNS required, S3 bucket required. The S3 bucket to store the state, DNS is to integrate all APIs. When you run a command, that request will go through this DNS only through API. Control node inside. That's what this DNS. That's it. Okay. Let's try today. Let me know. Okay. Okay. Next. So today concept is ECS. Already we discussed ECS in the last class. What is what? ECS, Fargate and all, right? So guys, ECS is a elastic container service, fully managed containers. Okay, this is not pod concept, container concept. No Kubernetes involvement here. So simple logic. We are my end 6 images are there. I want to create a containers. Those containers I need to provide orchestration. ECS platform will help. Clear now? My end images are ready. Those images you can deploy inside the Kubernetes or deploy inside the ECS. If you deploy inside the ECS, this is fully managed service. Kubernetes is not fully managed. Worker nodes you can take care, or worker nodes also if you can take FortiGate, not FortiGate, Fargate. Fargate also fully managed, 90%. Clear na? Okay. Yeah. So, but this is completely AWS. Understand? And you end to end you can deploy inside the AWS. But Kubernetes is not end to end AWS. Understand? On AWS, Kubernetes on AWS. Simple. Kubernetes on AWS. But ECS means completely AWS service. This is dedicated service. This is okay. So, for example, my end few images are there. You can take a decision where you want to deploy those images, containers or pods. If you need a pods, if you need a more flexible, more manageable in terms of security, network, storage and all, go for Kubernetes. But I don't want to manage everything. I need everything taken care by AWS. So my end, there is no much team to handle the things of this application and all. Go for ECS. Clear na? So Amazon ECS feature integrated with the AWS FortiGate serverless compute engine. Sorry, Fargate. Yesterday I worked with FortiGate. That's what. AWS Fargate makes it easy to focus on building your application by removing need provision of managing Amazon EC2 instances. So if you take ECS with Fargate, you no need to worry about the EC2 instances. Completely Fargate will give the resources to run your applications. Clear na? So Fargate also lets you specify pay. See, this is pay as you go. For example, your application use whatever resources you can pay for that only. But for example, if I take ECS, you can pay for ECS in EC2. Fargate. Yeah, now you can see, for example, ECS Elastic Container Service, ECR Elastic Container Registry. Don't confuse, huh? Elastic Container Service. Okay. So Elastic Container Service. So you can see this here. Okay, here only we can. So ECS container, ECS is a cluster now. ECS cluster hosting a EC containers. So those containers resources, deploy into the EC2 instances. These two are EC2 servers. So now you can see you explicitly provision EC2 instances. You are responsible to manage for EC2 instances and charged per running EC2 instance. EFS and EBS integration required. You handle cluster optimization, more granular control over infrastructure. So guys, tell me, if I take a server to run my container, I have to take care of server responsibility, server costing, server patchings and upgrades, and volumes, storage, everything my responsibility. If containers running inside the EC2, pods are running inside the worker node, right or not? You can compare with EKS also. But the same thing if I take ECS with combination of Fargate, not EC2 instance. ECS is a cluster. So Fargate is a serverless service, instance only but serverless. What benefits I will get? Fargate automatically provision resources. No need any scaling activities. You no need to perform auto scaling and all not required. Directly it will be scalable. Fargate provision and manage compute. Okay. Charge for running a task. So charge for running a task. You no need to pay for instance cost like ECS combination of EC2. Whenever whatever you require, you can pay for that resources only. Next. No EFS, no EBS integration is not required. Completely taken care by Fargate itself only. And Fargate handle cluster optimization limited control. Why? Everything managed by AWS, so control is very less. Guys, these and all stateless I'm talking about here. Stateless means front and back end applications point of view. Database, again, take RDS. Google means Google database. Azure SQL. DB and always normal process only. But when I'm talking about stateless applications and all, whether you can take ECS or EKS. Clear now? Okay. See this now. Yeah. Now you can see. If you can see here, these are the containers, guys. Okay. Containers running inside the EC2 instances. These complete orchestration taking care by ECS, cluster orchestration, ECS, how many containers and all. Same process, this scheduling and orchestration taking care by ECS, same like here. But here instances are missing, Fargate is coming. Fargate will provide a required resources from, yeah, AWS and only. Let's take directly. Now you can see. So now these containers required resources we are getting from this instance. This container we're getting from here, like this. But those resources, simply required resources for this container simply provided by Fargate. This is managed by AWS. Clear now? This is main difference. So if you take this process, you have some control. EC2 level, if you want to do something, if you want to implement something, anything. Same like AWS Lambda and AWS EC2. Here also, if you take a Fargate, you don't have any control in the resource level. Understand? So whatever required resources, it will collect from Fargate. This is completely serverless. Server is not there in our end. Clear na? And the best part is, if containers are pending here, EC2 not create automatically. We have to create a auto scaling. We have to integrate auto scaling, right or not? But here not requiring auto scaling. Automatically Fargate will increase the required resources, it will provide by Fargate, automatically scalable. We no need to create any auto scaling. So many benefits are there. Responsibilities are very, very less in the Fargate. Our responsibilities are. Okay. So here we have to understand a few things. One is the first is cluster. Components I'm writing cluster ECS cluster. So we don't have any CRD here. CRD means custom resource definition. There is a pod ML, deployment ML, service ML. We are writing in Kubernetes, right? We don't have like that here. Just they're giving us some process. We have to follow like that only. We don't have any customizing options. Cluster ECS, okay. And task definition. This is important. Task definition is a deployment process. Container deploy process. Like a deployment.yaml is there no? In Kubernetes. Here, task definition. Deployment.yaml, service.yaml, pod.yaml, these are the CRDs, custom resource definitions in Kubernetes. But here, only task definition. Okay. Next, after create a deployment, what you can do, create a service to give access, right? Here also service is there. If you compare with the EKS is a cluster. CRD, custom resource definition. Like pod, deployment, pod, etc. Same here also 3 service. So guys, I think you have already completed front and back end on container process, right? We already done that project, right? You create a front end container, back end container, and DB container. DB container also we discussed, and RDS also we discussed, right? In Docker time. So two images we built, front end image, back end image. We have deployed manually, right or not? We have deployed manually, Docker and -dt and all. So we have accessed this front end server, localhost server, and container IP, target IP. We already done, right? Those images, again, you can deploy front end and back end image. This time, don't run manually. You ran manually before by using Docker Compose. Also, we have done manually. Also, we have done, right? Docker Compose is a YAML file. But now, be ready with 2 images and database also. Don't deploy through Docker Compose. Deploy through task definition. Clear now? What is the difference between if I deploy through task definition, deploy through compose.yaml? What benefit will get here? Here ECS involvement is there. There is no ECS involvement in Docker compose time, right or not? What benefits will get if ECS involvement if I add? Very good. Automate next. Base. So if I run directly containers without ECS help, if I run manually or by using Docker compose or run through ECS, what benefits I will get? Hmm? What benefits? ECS are only, see ECS also create a containers only. What benefits? You can see here scaling and orchestration, right or not? Scaling orchestration means what? 4 containers are running. Always 4 will be there here. If fourth one deleted, automatically fourth one will create. But if you create doc manually, any fourth container will create. Orchestration you have to take care. But orchestration here, ECS is taking care. Scaling. 4 are not enough. Fifth one is required. You can increase fifth one, manually create. But fifth one automatically create by using task definition here. Clear now? So it's a orchestration and scalable. If you deploy through ECS. Clear now? Okay. Okay, let's try now and ECS first so that so you can just give here ECS, Elastic Container Service, highly secure and scalable and high available. See, Amazon ECS make it easy to deploy, manage and scale Docker containers running in applications, services and batch process, right? Okay, let's get started first. Click on the cluster here. First create a cluster, ECS cluster. Cluster name, you can give anything you can give. Naresh IT, I'm giving cluster name. Forget only I'm taking here. Create. So this ECS supports Fargate environment now. Cluster Naresh IT's creation is in progress now. Oh, it's a creating done now. Okay. So let's click on it. Active. Okay. So ECS just cluster created, but we have to add the definition to definition to this ECS cluster. So ECS can follow your task definition, right? This is just empty cluster only. We haven't hand out any containers information, images information to ECS now, right? So in this case, what I need to do? Task definition. If you want to deploy any container, should create a task definition. Click on it. We have a namespaces also. You can deploy, I know, different namespaces also, like same Kubernetes. Task definition. Create a new, see guys, task definition, you can manually configure, or your JSON file is there. You can directly copy paste the JSON file also. We'll see. Create new task definition. So task definition family, you can give any name. For example, I'm giving a front end. You can give any name, no problem. Launch type is Fargate. If you want to try, you can try instances also. Which type of operating system it is? Linux. Task says specify the amount of CPU memory reserved for your task. Each task represent one container, for example. Now my container required one CPU, 3 GB, for example. Now understand, when you create a container from this task, one container will create, that's capacity of the container is 1 CPU, 3 GB. Okay. Task role, leave it. Task execution role, create automatically, keep it as is. Next. See, now task contains what? Container information only, right? Task means here container deploy process. Container one I'm creating. Okay, container created from where? Image, right? So I'm just giving a container name also front end. Image Nginx I'm calling. But here, if ECR, if you deploy your images into ECR, browse ECR images, directly you can select your ECR image. Understand? Or you can copy paste also. Or you can copy paste like this, your ECR image. Clear now? So if you want to test your custom image, first deploy a Docker image, push into ECR. From there you can call here. So far we call ECR image into Kubernetes inside, right? Now same image you can call ECS inside also. Task definition inside. But same image we use CRD inside the Kubernetes. Custom resource definition AMLs, pod, deployments, replica set and all, right? Now I'm using into task definition inside. Task definition which is equal to deployment AML into the Kubernetes. So image, I'm calling directly public image Nginx. My no images are exist. Okay. Next. So this image, when you run a image, container should create, right? Container should run on which port you have to give. Clear na? Port name. If you want to give port name also, you can give port name. So AT protocol is HTTP. TCP is a connection protocol. Okay. Next. Now this is important. Resource allocation limits. Already I discussed into the Kubernetes time, right? Resource limits means what? Yeah. These are the limits for your container. Container is creating by one CPU. Sorry, here you can see. This is one CPU, 3 GB RAM. Okay, you can take two also, no problem. 2 CPUs, 3 GB RAM for the container capacity. Out of this capacity, yeah, you are giving some limitations. For example, you in Kubernetes pod taking resources from instance, right? We are giving us some set points, limits and all, right? If it will reach these limits, create one more pod like that, right? So my container capacity is this one. Out of this capacity, if my container reach 75% or 65%, immediately it will create one more container. So this is target value. Out of this target value, if my container reach 1 CPU, memory limit 1 in GB, soft limit. So if I give like this, if your container reach 1 GB and 1 CPU, immediately one more container will create. Okay. So can I say 50% my set point now? As capacity of the container is 2 CPU, I have given 1 CPU, is the capacity is 50%, for example. Okay. You can add environmental variable also here. Your backend pod, sorry, backend container communicate to RDS, right? You can give DB host, DB credentials and all, right? Okay. creating a two GB. Okay, got it. Two CPUs, 3 GB is not supporting 4 CPU, 4 GB. Okay, let's create task. Okay. So, okay. So task definition created. You can go to front end. So this is my task definition. Okay. Run task. If you run task, automatically it will pull the image and run the container. Clear now, guys? Next, I'm going to create a service to give access this container. Okay. Cluster is Naresh IT. Forget, you can give like this. Desert tasks. How many desert tasks are required here? 2 or 3 or 4. If you give 2, for example, if one is not sufficient, second one also will create. Understand? No minimum maximum here. If you give, this is a maximum only. If you give 10, up to 10 definitions, 10 tasks will create by your ECS. Next. So networking, coming to the networking here, you can give which VPC, which subnet, everything is there here. And load balancer required, right? The service and load balancer, use load balancing. Application load balancer required. Okay, select. Your and already existing load balancer is there. You can select. Or new load balancer is there. You can give ECS LB something. That's it. Target group also should create, right? ECS TZ. No tasks are running, right? Can I run task also now? I'm going to now run task also. Desert task I'm giving 2 versions. I'm not selecting. See, I have given how many desert? 2. So 2 is creating now. Running. How many containers are running? 2. Let's go to service. Tasks, you can see. Infrastructure. Forget. Metrics. Schedule task. You can create a schedule task also. Specific time to create. Configurations. Event history. Last 24 status you can see. Okay. Okay, let's move to now. 2 containers are running. Let's go for wait. Let's go to the cluster. Refresh. Yeah. 2 running, no pending. This is fine. Click on this. Already before you created service, right? North Virginia. Okay. Let's go and check any load balance created. Or let's create one more time. Provisioning. Okay. Wait. After create a provisioning, you can see the services and Target group inside. Wait for some time. Load balancer, still provisioning. Okay, let's create a service. Launch type, wait, replica, wait, already created, right? Go to load balancer, still provisioning, active. Okay, listener will updated. So go to target. How many containers? Why not registered? Okay, I got it. Service created right now. Okay, okay, let's try to access first. We can see how it is working. Okay, go to here, load balancer. Targets not updated. Yeah, now updated. Okay, it's taking time to update the targets. So yeah, 2 targets updated now. So let's access now. It should work definitely. Oh, SG is also there, right? Thanks. Go to load balancer. This is the load balancer. Security. Okay, inbound rule I need to change. Now you can access. Clear now? So ECS like this. I will create one more cluster. Tasks. These many tasks are running. How many? 10. Why? Hmm? I'm not getting. Go to task. I given 10 na? Oh. Then why 12 running? Update cluster. Okay, go to task definition. This is my task definition. Update. You can click on it. Update. Oh, I given 10. I thought. Okay, let's give 2. So it has to be delete. Ten request, 10 running, right? Now I have changed it to 2, right? This has to be reduced to 2. Let's see now. Stop it. See, deactivating. Refresh. Deactivating. So I have changed it to 2, right? But why additionally 2 is running? Huh? Okay, let me verify now. 4 will be running now. We'll deploy. I will deploy 2 tasks. Let's go to the task definition. Okay, I'll do one thing. Keep as is. I'll create one more task definition. We can test it. Okay. Create a new task definition. You can give, for example, forget 1 CPU, 3 GB memory, container, HTTP will take it, right? Let's give public image. Name HTTPD. So image also HTTPD. So container port, okay. If you want name HTTPD, I want HTTPD image. So resource allocation limit condition, container level CPU. Okay, give 1. Here also 1. Soft limit, hard limit, there is a difference. Okay. Hard limit 3 is the highest. It won't cross. 1 is a soft limit to do some action on top of it. So you can give 2 also, no problem. Or 1 also. Okay. That's it. I'm not giving any number here. Okay. How many required and all I'm not giving. Just I'm selecting in the task definition or what resource limits and which image, which port. Only I'm giving in the task definition inside. Clear now? Okay. Create task definition. Now total how many tasks? 2. Total 2. One is for HTTPD, one is for task definitions. Clear now? Okay. Let's click on the task definition. Let me here run task here. Okay. So here I'm giving desired task is 1. Okay. Let's see now. Task group. I think it won't not required. Forget. Okay. 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 Create. Okay. Click on it here. Let's check it now. You can see containers here, the memory allocations and all also. Click on array sheet now. Tasks. See, one more task is provisioning Vira. Okay, how to give access to this task now? Create a service. So click on array sheet here. So number of tasks, which, yeah, this is the one. So go to task definition here. This is the task. I'm creating a service to the task to give access. You can give any version or not required also. Service name, you can give anything here. Environment, launch template. Specify number of tasks. 2 I'm giving. Next, what type of service? Load balancer. I'm creating a use load balancing. Application load balancer. Create new ALB for HTTPD. Target group also. HTTPD TZ. Create. Wait for some time till ALB create. Okay. Till creating, wait for few minutes. Okay, let's go and check. Load balancer. Yeah, this is also provisioning. Wait for some time. Refresh. Yeah, active. Click on it, load balancer. You can check here, listener rules, HTTP TZ. You can click on it. See, one is initial, total 2, right? I have given 2 only, right? Desired state. So total 2 targets now. Healthy now. Let's take now. Yeah, security group, I think it will take same one or different one. Let's check it now. Go to the load balancer. I think it will use same load balancer as I have given default section, right? Yeah, default. So definitely no need to change anything. Clear na? Okay. And now tell me guys, one application, I want 10 containers, 10 replicas for one application. How many task definitions I should write? Task definition 1, number of tasks 10. Each task equal to one container, guys. Understand? For example, let me access what I'll tell you. It works. Clear na HTTP response? Okay. So what I'm trying to say, yeah. So total how many definitions are there for me? 2. This task definition represent different image. This task definition represent different image. Clear na? While creating that desired count I'm giving, right? See total how many containers are running here? 2. 2. This is CPU max allocation containers. See, this is total CPU, guys. Out of CPU, I have given max memory set point is this one. Understand? Okay. Let's go to now back to task definition. This is task definition. So now you can go to cluster. You can click on it. You can see total how many tasks are running? 2 tasks. Yeah. See total 15 tasks, including 2. One is for HTTPD. One Vera represents is HTTPD one. Front end represent is front end. Clear now? So front end is a one task. This task definition. See, this container created from which task definition? This task definition. This container created from this task definition. Total how many definitions are there? 2. Clear na? If you want to create a third one, create a task definition. Create a number of containers. Again, clear na? If you want to do any modifications, update service. Which service? This one, right? Yeah. Cluster is common. That's what, see, which service you want to update, it is asking now. This service I want to update. Okay. So desert task are given 2. So this is high availability. Always it will maintain 2 tasks. Understand? Even 1 down, 1 will be work. 2 down, complete application down. Clear na? Always 2 work. 2, you know, number of tasks 2 means total 2 containers continuously running. Okay. Yeah. But if you give 1, no high available. If the container is down, application also down. So this is max set point. And minimum set point is not there here. Clear na? 2 task definition immediately will create. 2 tasks immediately will run. But required resources Fargate will provide. Understand? See here. Yeah. So Fargate is providing here. These 2 containers created from where? Desired count is 2. Right now. So even 1 container down now, 1 is working. But these 2 containers required resources providing from where? Fargate. How many containers decided by? Desired count. Each container required resources gives by Fargate. How many resources should give? You have already given a set point. 1 CPU, 3 CPU, something. Clear now? Like that. Here, if you compare here also replicas. Replicas concept is there na? I mean, in Kubernetes I'm talking about. Replicas, if you give it to 2 pods will create. Required resources will give from EC2 instance. But here, Fargate. That's what the difference. Sorry. Yeah, correct. It will create another container, but it should be run two different tasks. For example, here you can see if I give one task only, okay, what happens? Let's go to modify, update. Okay, one task will given, right? Anyway, you can ignore this error. How many tasks? Now you can see if I give two now, turn on availability zone rebalancing. See, Amazon ECS automatically detects availability zone and task distribution across ECS service evenly distribute ECS services availability zones. One service running on one AZ, one service running on one Z. Even one AZ fail also, still your task will run. That's what they are saying. If you give one, uncheck this. If you check, one is not sufficient, right? Okay. Update. Where? This, the max running task value must be greater than the minimum. Then this case, 150. Okay. Why this is not taking? Let's give two. Updates. Why it is not taking? Refresh once. Oh, got it. This is shut down. That's what the problem. Okay. Open sandbox. Again, login. Username. Password. Okay. Sign in. Okay. ECS. Get started again. No express mode, directly we can go. So first is what? Create a cluster. Some it's taking some name, you can give same name also, no problem. So I'm taking again Fargate only. Fargate plus manual instance, both also we can give. Cluster is creating. Next is what? Task definition. Namespace also, if you want, you can use also. Yeah, cluster is creating. So same process I did through Terraform also, guys. Repositories, ECS. Okay. Now you can see ECS task. Total how many task definitions required here? Two. So one is for backend, one is for front end. This is for cluster creation process. This is IAM role. This is data source for VPC subnets and all. If you click on the front end, now you can see load balancer, target group, listeners, task definition, service. Clear now? Now desired count is what? One only I'm giving. So like this, you can also try with Terraform also. So only you have to change here image path. That's it. So target groups, which port your container is running, change the port number here. Listener is common always 80. If you know, if you use HTTP, if you want to use HTTPS, give 443 and certificate also we have to update. Yeah. Same backend also, backend task service. You can see here. Backend load balancer, backend target group, and task definition for backend. So memory CPU 512, 256 I'm giving here limit. CPUs. So these are what? Environmental variables to connect your database backend. And ECS service, backend ECS service to create a backend ECS service. Same front end and backend two services. So include, you can separately write also. If you want to write uh, service instead, I'm adding, right? Service load balancer, target group, listener, separately you can create. Task definition folder separately you can create. But I have added everything into the same code only. Clear? RDS also there. Database. VPC network. Use this process for the deploy a project better. Even manual process also fine. Okay, cluster is still okay. Cluster is created now. Next is what? Task definition. Create a new task definition. See here JSON. JSON process also there. Okay. Your and already JSON file is there now. What and all required minimum, maximum and all. For example, like Terraform. See here. In Terraform, so I have given task definition right here. Manually, whatever steps you are selecting, right? All are given like a JSON till here. Clear now? Like this also you can do. Okay, let's move to JSON file or manual process. So go to cluster. Okay. So nothing is running. It's empty cluster now. I'm creating a task. It's a blueprint. Task definition is a blueprint to create a container. So create a new task definition here. Give any name here, your wish. So I'm giving Veera again. AWS Fargate. So specify the amount of CPU memory to reserve your task. So I'm specify for 1 CPU, 3 GB RAM as is. Role automatically create. Container name you can give which so task definition will create a container, on which name container you should create. You can give something, anything. Which image container has to create Nginx. You can give your ECR image. Which port the container should run on. You can give something, anything you can give like this. Yeah, resource and limits. It's a conditional base. I'm giving a 1, 1, 1. And environmental variable I'm not using. That's it. Okay. So yeah, you can see here. Yeah, that's it. So here only you can create a load balancer also. Or after complete task definition process, again you can click and create a service also. Anything is fine. So at same time you can create a load balance also. You can create service process is not there here. Okay, let's create. Okay. So this is CPU memory. I have allocated only 1 GB, right? So you can see only 1 GB. 1 CPU, 1 GB. Details. Okay. So task definition is ready. So can I run task now? So service is required, right? Or you can create a service and run task also, fine. Okay, I'm going to run a task now. Yeah. So specify number of tasks to launch. You can give it 3, 4, 5 like this also. Or 1 also. Okay. Yeah. Click to networking. So which type of service I'm creating now? Load balancer. Where is the option? Yeah, create service only here. Networking, I can see. Yeah, yeah, now updated, right? Previous was updated, huh? Oh, I click and run task. Okay, okay. Okay, so let's create a load balancer. ALB, you can give anything. Clear, na guys? Target group name, this one you can give like this. Create. So service is creating, then you can run task also. Or first run task, then create a service also, fine. So manual process little confusing than Terraform is better. So guys, understand task definition inside one container features, one container required metadata information you are giving. Service inside how many tasks required desired capacity you are giving. Okay, don't confuse. See, task definition inside, we don't have any option to choose how many containers. Just each container requirements. Task definition is each container requirement. So how many tasks are required while creating a service, you can give a desired. That's it. See, while creating a service, desired as 1 or 2 we can give. ECS service. And these two accessible for load balancer. Clear now? And one task when create in, if two, one task create in one AZ, one task create in one AZ. So one container run in one Fargate profile, other other container running other target profile. Okay. I mean, here by seeing the architecture, we can see Fargate is the only one, right? But this Fargate, for example, this is maybe 1A, 1B, 1C. So two containers, if you want to deploy, first container here, first container here, 1A, 1B. Clear now? Mm. So task get to run, right? Created service only, right? So let's go to the cluster now. This is my cluster. So number of tasks, run new task. I'm creating a new task now, okay? Which definition? My definition. Desired task. So I'm giving only one. Capacity provided strategy and all you can give. Create now. Yeah. So task is provisioning now. Running. Okay. So go to service. Service also updated already, load balancer. Click on it. Go to target group. So this is the target group. How many containers registered here? One. Initializing. So you can go and access load balancer. You'll get yes name. Oh, SG. Edit inbound rules. So by default it is taking SG. So default SG. I'm giving all traffic. Okay, but in Terraform, Clearly I mentioned here which SG has to take. You can see here back VPC network, right? So I have given SG group also here completely. NAT gateway route table. See SG required 80.22.2306 only. Backend should communicate to 3306 through RDS, right? That's what this is whitelisted. 22 whitelisted, 80 for everyone whitelisted. Yeah. So before, if you want to start Terraform, what you need to do? Build the images first. Build images, push into your ECR, and then do this. Okay. Backend image, front end image. So let's go to here. Yeah. So first you have to create a backend. Clear or not? For example, okay, let me show you otherwise quickly. Okay. But if I want to show RDS, I should create, right? Amazon RDS. Okay, guys, I'll guide you what to do. Okay. You can practice. Okay. So be careful, huh? What I'm saying. Please listen. First, you can deploy RDS. Okay. And run test.sql script. Right or not? Run test.sql script. So here database will be created from this test.sql. Clear now? Next, I'm talking about ECS. Okay. Next is what? Run backend. Backend. So if you want to run backend, first you have to create a backend task definition.yaml, right? Task definition.yaml. So task definition.yaml call which image? Backend image. So you should build a backend image first and push into ECR. So your backend image and database, how both can communicate? Environmental variable. See, while creating a task definition, for example, let me create one more task definition. While creating a task definition, it is asking here env variables, right? So your backend image inside also. So whatever .env we are using, same also we are using. See here. Yeah. File also you can add directly. Here what we can add? DB host value from RDS also you can select, or directly you can copy paste also. Clear na? The value whatever you want to give. For example, this is done. Next is what? So DB host value is this one. Next is what? DB username value is admin, for example. Next, DB password automatically coming my end. Okay. If you want add port number also, port. So your backend now trying to communicate RDS. Clear na? Let's go to .env. See guys, everywhere these key names are common. Env variables. You are not supposed to use different one. So DB post something. These are all common in my .env inside also, right? So now you no need to build .env. Understand? So you can remove .env. Anyway, my Docker file inside, you can see .env I'm not using, I think. np install. Okay. You can remove .env file, guys, before build. Okay. Yeah. And next, create a backend service also. Backend service load balancer will create, right? Take that load balancer. Don't get a front end service now. After backend create and access hello response will get it, right? Take the backend load balancer URL. Go to front end code. So your code is there now. Here you can add backend load balancer URL. Then deploy front end image also. Then deploy front end image and push into ECR and create a front end task also. Front-end task also create a load balancer, right? That load balancer, how you can access. Clear na? First, front-end load balancer, if you access request will go to where? Back-end load balance. Back-end load balance request redirecting into database. Clear na what I'm trying to say? Your wish, if you want to do through Terraform also, I'm fine. But one thing you need to understand here. Terraform, you can see here Terraform. Let me tell you, Terraform process. So Terraform, it will run two YAML files at a time. Sorry, two task definitions at a time, right or not? Including same code, right? But manual process, we are first completing a backend, then front end we are doing, right? But coming to the Terraform, it will take complete stack. Front end, back end will deploy same time. You can separate it also, okay? Or what we can do, my easiest task inside. So my images, what I did here actually, let me tell you. Yeah, front end. So what happened exactly here? This image is there now, front end image. Before that add this front end image, before deploy this front end image, I use Route 53 DNS. Clear what I'm trying to say? For example, my front end code inside. I don't know my backend load balancer at this time now, right? While creating a Terraform, I don't know. Both are creating same time, front and backend. So I don't know my backend load balancer URL now to give my front end code inside. In this case, what we can do, create a Route 53 domain once. Give a false address. The Route 53 domain name you can use inside the front end code. Later backend load balancer create na, go to Route 53, map exactly load balancer. That's it. So for example, my Route 53, yeah. Now you can see. See, Pluralsight already giving a Route 53 dot, right? Route 53 domain, right? So public one you can take. So this is already work, right? What we can do, take this domain directly or subdomain, copy and use, add into your front end code inside. So front end code redirecting into this domain. This domain is already record now? No. As of now, no record. I mean, A type record are not there, alias record also not there. I don't know my backend load balance at this time, right? But front end code is communicating to this domain only. So front end code inside you can add this domain or your domain and deploy it and run a task also. Front end, back end, everything run. So after success, you are unable to access first time. Then what you need to do? Open Route 53, create a record for no, don't give any subdomain. You have hard coded into code inside same thing, right? So alias to back end load balancer. Now communication will start front end to back end to DB. Clear now? That's what I'm saying. Or you can do one thing also. It's a little complex one. You can use the outputs for the front end. You can call from the back end also we can use, but no need. In real time, we are not deploying front and back end in same Terraform stack. First back end, then front end only we can deploy. Clear na? Okay. So like Ingress, no. See, this will support path-based routing. Understand the reason this is AWS native platform, but Kubernetes not support path-based routing. That's what we use Ingress. Understand? But ECS is completely AWS process. It will support path-based routing. I'm taking application load balancer, right? So each path you can deploy image. Each path you can deploy image. Each path you can create a task definition.ml. Each task definition you can call same load balancer, existing load balancer, existing load balancer, existing load balancer. So automatically background target groups will create. Each see what I'm trying to say now. Your end multiple paths are there. For example, this is cart. Okay, this is orders. Two cards are there, right? So how many task definitions will come? Two. how many images will come first? 2 image, image. Clear na? From this image, you can push into ECR, ECR. And next is what? Task definition. I'm adding a TD, task definition. Here also TD. Clear na? So task definition time, you have to choose here. Okay, you have to choose here load balancer target group, right? Service creating time. So first time you're choosing a one load balancer, one target group, right? Second time creating time, choose same load balancer again, existing load balancer. But target group you can change. Clear na? So same load balancer map to how many targets now? 2 target groups. Clear na? One target group responsible for cart, one target group responsible for order. But you should deploy one more image. For what? Home. End user don't know, right, how to use load balancer cart, load balancer orders. End user need UI page. If end user click on this should redirecting into cart, or this should redirecting into order. Same thing we discuss in AWS something, right? Path-based routing. Yeah, 3 images will come now. Home represent for UI. If user click on the cart, request redirecting into cart, load balancer redirecting into target group. Clear na? Like this. You can deploy the project we deployed on the EKS, right? You can deploy in ECS also. Okay. Clear everyone? Okay guys, so ECS forget also important concept guys. Please add in your resumes first. Okay, today practice. If you are facing any challenges, let me know. Tomorrow I'll explain. CACD process is what? CACD process is first deploy a image, build a image, deploy image, and image into ECR. So now ECR to you can call into update into task definition inside, right? So we use Lambda function actually here. Lambda, whenever ECR update the image, automatically replace the existing image. Clear now? That's all for today. Thank you. I'm not saying like that. Different. Most companies, small scale companies, medium level companies, large scale companies are there. Definitely large scale companies go for Kubernetes. We have a flexible in terms of security, in terms of CRD, but ECS limited options are there, right? So but ECS flexible for cost. ECS cluster free. Container only we have to pay. But Kubernetes cluster EKS is not free. Whether you deploy or not, EKS cluster is running a EKS cluster also you have to pay hourly something. So this is expensive, but more control. Multiple applications we can deploy, but it is not support multiple applications. There are some hard limit for ECS. ECS you can deploy microservice, but not multiple microservices. Understand? Yeah. For example, here EKS, your end 10 applications are there. Simply go to Argo City, you can deploy. But here is not like that. Task definitions, you have to write 1, 2, 3, 4. So definitely some challenges are there, flexibility. If you want to give access to someone, understand, control. If you want to give a control, Kubernetes pod level also we can control. But in ECS is not like that. IAM level control. IAM, what we can do, IAM, if we can give any policies, we have to write custom policies, we have to write, still somewhere security will be breached. Right or not? But Kubernetes RBAC is very flexible. We can give whatever you want. Like that, some features are more in the EKS compared to ECS. Yeah, ECS is just user involvement is very less in terms of running operations. I'm saying. So once you deploy, leave it now. Relax now. No need to do anything. Yeah. Clear now? Okay. Thank you. Bye. So 2 tasks I have given. Task number 1, COPS. Task number 2, ECS Fargate. Yeah, we have a class tomorrow. Okay. Same time, 10 to 11:30. Okay. So guys, if you attend Saturdays, whenever you require, I'll give a holiday. Jan 1st, I have given holiday or not? All remaining trainers already taken a classes. Data science already classes taken. Different DevOps trainers taken classes. But when your festival will come, if you require, I'll give 2 more holidays, 1 more holiday extra. I don't have any problem. But work Saturdays. Now all are festival season, right? Coming days. Yeah, that's what. For example, Naresh Shetty is given 3 days holidays. If required, I can give 2 more. Understand? Yeah. Please understand. So Saturdays, please attend the classes. This Saturday also class is there tomorrow. Thank you.